So welcome to Computational Physics course, PHY 3242. I am Samir Lakshan. I am currently a probation lecturer at the Department of Physics. So my email address is given here. If you have any questions, you can email to my email address, or also we have this WhatsApp group. So if you have any questions, you can use the WhatsApp group also to ask your questions. Now, these are the total content that we are going to discuss for this PHY 3242 computational physics. So first we will discuss about the computational physics, what we can do using computational physics, and what is this computational physics, basically introduction about the computational physics. Then we'll discuss about computer arithmetic, what are the number systems and how we can use those number systems. Then when we are dealing with this computer arithmetic, when we are doing computer calculations, they are all there. Every time there is a possibility for errors to be occurred. So we'll discuss about those errors and uncertainties in computation. Then afterwards, the numerical differentiation, numerical integration, solving linear equations, and interpolation are the topics that we are going to cover during this course. So basically, those four topics are numerical methods, and we'll apply computer programming for solve these numerical method equations and these mathematics to obtain certain solutions. And we'll discuss what will happen, what are the advantages of certain method, what are the disadvantages, and how we can approach these methods. So we'll discuss about those in the last four topics. Now, these four books are the references for this course. If you can find these, it will be better. So this computational physics by Rubin Landau and Introduction to Computational Physics, also an Introduction to Computational Physics, Computational Methods in Physics. So these are the references that I'm going to use. Most of the time I'll refer to this Computational Physics by Rubin Landau and other authors. So if you can find this book, it will be really good. Now, what do you know about computational physics so far? So I think all of you have followed mathematics, physics, as well as computer science, right? So computational physics is an interdisciplinary study in all these subjects. So it will involve computer science, mathematics, and physics all together. So we'll use this computational physics to solve complex numerical problems, to solve realistic and ever-changing physics problems. So every time when we deal with some physics problem, it can be a complex situation, or we want to obtain more realistic results. So whenever we want to obtain more realistic results in these ever-changing problems, we can use this computational physics. So once we have a certain simulation, or once we have a certain computational physics program, then once the physics problem is changing, by changing certain variables, we can obtain a new result. So for these ever-changing problems, when we have a proper computational physics program or a arithmetic, then by changing certain variables, we can obtain new results once we change the variables and other parameters. So what do you know about computer science? What is computer science? In computer science, what you have done so far? So what you have done so far in computer science? So mainly in computer science, these computer scientists, they will try to develop hardware and software that these computer scientists will use. So in computer science, computer scientists will try to develop. So they are developing hardware and software that the computational scientists use. In mathematics, what do you do? In mathematics, what do you do? So in mathematics, you are either developing or analyzing or investigating, studying algorithms, mainly these mathematical equations and formulas, algorithms. So you are analyzing those in maths, mainly in mathematics or applied mathematics. So for this computational physics, mainly applied mathematics will be used. So in applied mathematics, you will do those things. Then what do you do in physics? So what is physics is mainly about? So if I ask from you what is physics, what will be your answer? If I ask from you what is physics, what will be your answer? Can someone tell me? So what is physics? What have you done so far when you are studying physics? So in physics, we mainly study about the interactions of energy and matter. So if I consider about electromagnetism, we see what will happen when charged particles interact with each other. What will happen when we place a certain charge in a magnetic field? So in electromagnetic, we see those kind of interactions. Same like that, we have atomic physics, nuclear physics, particle physics, in many branches of this physics. So in each of these branches, we are studying the interactions between energy and matter. So what will happen between these interactions? So computational physics in this diagram, CP, is an interdisciplinary study of this physics, computer science, and mathematics. Also, we can say with this computational physics, since it is connecting each of these physics, mathematics, and computer science, so with the help of computational physics, mathematics can be developed, physics can be developed, as well as computer science can be developed. So with these physics, mathematics, and computer science, computational physics is developed. Also, with the help of computational physics, physics concepts can be developed, computer science concepts can be developed, as well as mathematics concepts can be further studied using this computational physics. Now, why studying of this computational physics is important? Why it is important? So if you look into this diagram, now all the physicists or scientists, they want to discover about the scientific nature or about the nature, or they want to uncover certain truth. So for those scientific truth, now scientists will conduct experiments. So using the experiments, they will obtain data. So in your laboratory sessions, you are conducting experiments, then you are obtaining data. Then also you have theory. So using the equations and other concepts, you have theory. Then also by simulation. So simulation is kind of like a virtual experiment. So you will be conducting an experiment, but not in a real laboratory conditions. So simulation will be conducted within a computer, but in those simulations, theory will be involved, and also some experiments will be involved. Using the simulation, also you can gather data. Now, in most recent days, for recent researchers, these all three experiment, simulation, and theory are required to obtain a very good scientific truth up to a good probable condition to obtain the scientific truth up to a good confidence. In order to obtain the scientific truth, you need all of these three concepts to be involved. So you'll be evaluating and exploring the scientific truth using simulations, experiments, and theory. So theory is involved equations and concepts. Then experiments, you have laboratory experiments. In a simulation, you will develop a virtual environment which is involved in theory and experiments to gather data and to get more insights about the experiment. So in certain experiments, there can be like the variables that you can control might be very limited, but in a simulation you can add more variables based on certain assumptions or certain like relative to each other. So likewise, you can add more variables in a simulation. So you can gain more insights about a certain theory or experiment when you conduct a simulation. Now, these simulations will be mainly based on the computational physics methods. So you can, using the computational physics methods, you can develop certain simulations as well as you can do computational calculations. So calculations will be used in all three here. Likewise, computational physics is mainly involved in identifying scientific truth in research for evaluation and explore the concepts. Okay, so that is the importance of computational physics, and mainly we can describe computational physics. So it is involvement of physics, mathematics, and computer science to solve complex numerical problems in a realistic and ever-changing physics problem to solve those. Okay. Now, I can remember there are a few biology students here as well. They have asked whether they can follow the course. So in computational physics, so these computational methods will not be limited to physics. So in order to solve biological problems, chemical problems, chemistry related computational mathematics, so we can use these computational methods. So you have computational chemistry and computational biology. Likewise, there are several other branches in the same way, but the main scientific concept is different in those conditions. Okay. Now, to solve these complex numerical problems, we are using computer methods. In a computer, we have the basic hardware, and hardware is surrounded by the, in this diagram it is shown, the hardware is surrounded by the increasing higher level of software. So we have kernel, then utilities, shell, and then the graphical user interface, then the program development. Now, how hardware communicates with the software? How a hardware, how not a single hardware, so hardware will compose of several components, how this hardware will communicate with software, how it will happen. What do you know so far? So in hardware, we need to, at the moment, for this electronic based hardware, to communicate with the hardware, we need a binary system. So binary systems will be like 1001, 1100, likewise only ones and zeros. So we need a basic machine language to communicate with the hardware and the software. And if we have a basic machine language, let's say a low-level language, then using a low-level language, we can say how each number is stored and how we can communicate with the one memory location and another, and basic binary arithmetics, those will be communicate within the software and the hardware initially using the basic machine language. And then what are the kernels that you have heard of? What are the kernels that you have heard of? Have you heard about this Linux kernel and Windows NT kernel? Have you heard about those? Linux kernel. So these kernels, this kernel will provide the basic functionality for the softwares as well as device drivers. So kernel will provide basic functionality and device drivers. because of the basic functionality provided and based on the device drivers, kernel will do three fundamental operations in a computer. So a kernel will provide interface required to user and application to interact with the computer. So in a computer, you have, let's say you are doing a certain program. So you are the user and you will be developing applications. So kernel will provide the interface required to user and applications to interact with the computer, in this case, mainly the computer hardware. And also this kernel will launch and manage the applications. Okay. And it also, since it is providing the device drivers, it manages the system hardware devices. Okay. So those are the main three functions that can be done using a kernel. So it provides interface required to user and applications to interact with the computer, and it launches and manages applications, and also it manages system hardware devices. Then we have utilities, and then the shell, graphical user interface, and program development. So certain utilities are required to communicate with the kernel and the shell. So like programming languages and these device drivers. Then what are the computer shells that you are aware of? What are the shell? What is a shell? What do you know? So when we are writing and running a computer program, we need to use the shell to communicate with the computer and the high-level languages. So what are high-level languages? We have Python, Java, Fortran, C. Likewise, we have high-level languages. So in order to communicate with the computer and these high-level languages, we need a shell. So if you are using a Windows operating system, you can use command prompt as a shell, and also you have this PowerShell, those applications to operate as a shell. Then we have the graphical user interface. So graphical user interface, we have Windows, likewise Linux and Mac OS, like those. We have graphical user interface in a computer. Then we have the program development. So when we open a new program or when we are coding, let's say we are coding using Java and we are opening a new window, so that we can call it the programming development environment or the program development. So for example, we can say applet view. Okay. Then regarding these computational physics languages, so we mainly have the computer hardware, then we require machine language, this machine language. So we can communicate with the hardware using binary. So machine languages will be in ones and zeros. Then we have assembly language. So assembly language will be a little bit easy to understand by a human. And assembly language examples will be like, we will have certain commands like add, move, subtract, and with the certain memory locations. So it'll be a little bit user friendly. Then we have high level languages. So high level languages are better user friendly. So by looking at the code, if a certain person have used this language for a while, then they can identify what are the instructions given in a high level languages. For example, in Python, Java, Fortran, C, like those high level languages. So now we are going to use this these computer programming languages to solve certain physics and mathematical problems. So for this course, I'm going to use Python programming language. So Python is a high-level general-purpose programming language, and it is designed philosophy emphasized readability with the use of significant indentation. So if you have access to this slides, I have given web links for the Python download. So if you click here, it will open a window to download this Python version. So current latest version is Python 3.12.4, and it can be installed for any of these operating systems: Windows, Linux, Unix, Mac OS, or any other systems. So you can download this Python using this web link given. You can see my web browser, right? Can you please let me know whether you can see the web browser?
Yes, sir.
Okay. So you can either download the latest version, or I would recommend either Python 3.10 or 3.9. So you can download those like little bit stable version. And what are have you done any Python programming previously? Have you done any Python program previously? Any prior experiences? So to run this Python code, so we will write several codes, and to run these codes, we have several methods. One way is to use if you are using the Windows or Linux, then you can use the command prompt or the terminal. And also we have some virtual environments like PyCharm or Jupyter Notebook, like those environments. So you can download the Python using this link, and using either Python version, you can go with any Python version. And if it is properly installed, so you can open the command prompt in your, if it is a Windows laptop, command prompt or the terminal. Then if you type Python as a command, so if you type Python as a command, then it will indicate the Python version. So here I am using Python 3.9 and 3.9.133. So then you can run your codes using the command prompt as well. And for this course, what I would suggest is to use this Anaconda platform. So Anaconda platform is a free Python distribution, including more than 125 packages. So those packages will be in a vast range: science, mathematics, engineering, and data analysis. So there are several modules mentioned here. And Anaconda is a self-described, enterprise-ready, large-scale data processing, predictive analytics, and scientific computing. So there are many uses of this Anaconda environment. So you can access the download for that one also if you click this link. So you can free download this one, Anaconda environment. So you need to provide the email address, and then also you might be able to go with the skip registration. Yeah, then you can download this Anaconda environment using this web link given. So it is available for Windows, Mac, and Linux. So shall we download this Anaconda environment and install that one. So follow the link and download and install this Anaconda environment.